In this session, we will learn about orbital overlap and hybridization. Let's start with orbital overlap. First, we will discuss about valence bond theory. As you know, covalent bond formed when electrons being shared between two atoms to become octet. According to this theory, a covalent bond between two atoms is formed when a pair of electrons is shared by two overlapping atomic orbitals. Atoms in simple molecules or ions such as hydrogen, hydrogen fluoride, and nitrogen molecules normally use pure orbitals such as s and p orbitals in forming covalent bonds. Examples of pure overlapping orbitals are s overlap with s orbital, p orbital overlap with p orbital, and s orbital overlap with p orbital. There are two types of overlapping orbitals that we will learn. The first one is overlapping end-to-end, which lead to the formation of sigma bond. And the second one is overlapping side-to-side, which leads to the formation of pi bond. Okay guys, let me use HCl as an example for you to understand more about the valence bond theory and to show the bond formation by the overlapping of atomic orbitals. Hydrogen has one valence electron which is located in one s orbital, while chlorine has 7 valence electrons in 3s and 3p orbital. For hydrogen and chlorine, both need one more electrons to achieve octet. As we can see, the unpaired electron in hydrogen is in 1s orbital, while the unpaired electron in chlorine is in 3p orbital. So, each atom shared one unpaired electron to form a covalent bond. By overlapping 1s orbital of hydrogen with 3p orbital of chlorine end-to-end, a sigma bond of HCl will be formed. Now, let's have a look on oxygen molecule to see another types of overlapping of atomic orbitals using valence bond theory. Oxygen has 6 valence electrons, which is located in 2s and 2p orbital. It will share 2 electrons with another oxygen atom to achieve octet. From the Lewis structure of oxygen, it has 1 sigma bond and 1 pi bond. The unpaired electrons in 2p orbitals will overlap in order to form sigma and pi bond in the molecule. By overlapping 2p orbital of oxygen with 2p orbital of another oxygen, end-to-end, a sigma bond of OO will be formed. Next, by overlapping 2p orbital of oxygen with 2p orbital of another oxygen side to side, a pi bond of OO will be formed. So, we already finished with valence bond theory. After all, you can try applying this theory to another simple molecule such as nitrogen and chlorine molecule. Alright guys, in previous lesson, we had learned about overlapping of pure orbitals to form the covalent bond. Now, in this session, we will study about the hybridization. What is hybridization? It is mixing of two or more atomic orbitals to form a new set of equivalent hybrid orbitals. Hybridized orbitals are very useful in the explanation of the shape of molecules. We can relate electron groups of the atom in the molecules with the types of hybridization. For 2 electron group atom, it involves mixing of 1 s orbital and 1 p orbital. So, we will have a hybrid orbital named sp. 3 electron group involve mixing of 1 s orbital and 2 p orbital. So, we will have a hybrid orbital named sp2. 4 electron groups involve mixing of 1s orbital and 3p orbitals. So, we will have a hybrid orbital named sp3. 5 electron group involve mixing of 1 s orbital, 3 p orbital, and 1 d orbital. So, we will have a hybrid orbital named sp3d. 6 electron group involve mixing of 1 s orbital, 3 p orbitals, and 2 d orbitals. So, we will have a hybrid orbital named sp3d2. Now, we will learn about hybridization process. Before the hybridization process, make sure we already have the correct Lewis structure. Let's look at the first example, BF3. From the Lewis structure, we can see there are 3 sigma bonds, indicates that it has 3 electron groups. The electron group arrangement is trigonal planar. From Vesicle theory, this molecule has bonding pair repulsions, makes it trigonal planar shape. 3 electron group also indicates that it has sp2 hybridization. Now, let's have a look at the hybridization process. This process involves 3 steps, which are writing the orbital diagram of valence electron at ground state. Let's have a look at the hybridization process. This process involves 3 steps, which are writing the orbital diagram of valence electron at the ground state for central atom, promotion of electron, and finally, write the hybridization state. The hybridization is only focused on the central atom and terminal atom that involves multiple bonds. In BF3, we only focus on hybridization of boron. Okay, let's go to the first step. Valence electronic configuration of B is 2s2 2p1. So, the orbital diagram is represented like this. For the promotion of electron, we have a look at the central atom of our Lewis structure. All the 3 bonds are sigma bonds, so we need 3 single electrons in the orbital. Since electron in 2s orbital is in pair, so we need to promote one of the electron to the empty 2p orbital. Next, we need to mix 2s orbital and 2 2p orbitals, since the hybridization is sp2. This is a new set of equivalent sp2 hybrid orbitals. Since this 2p orbital is empty, just leave it like that. Okay, let's learn how to draw the orbital overlapping diagram. The sp2 hybridization has trigonal planar arrangement. First, draw hybrid orbital of sp2 and label each of it. The BF sigma bonds are formed when each sp2 hybrid orbital of B is overlapping with 2p orbital of F. Since here we have one unpaired electron. Since there are 3 fluorine atoms, so 3 sigma bonds will be formed. Don't forget to label the atoms, orbital, and the sigma bond. Now, let's move on to the next example, HCN. Let's focus on carbon first. From the Lewis structure, we can see there are 2 sigma bonds, indicates that it has 2 electron groups. The electron group arrangement and its molecular shape is linear. 2 electron group also indicates that it has sp hybridization. Okay, let's go to the first step. Valence electronic configuration of carbon is 2s2 2p2. So, the orbital diagram is represented like this. For the promotion of electron, we have a look at the central atom of our Lewis structure. It has 2 sigma bonds and 2 pi bonds, so we need 4 single electrons in the orbital. Since there is only 2 single electrons, promoting one of electron from 2s orbital will give us 4 single electrons. Next, we need to mix 2s orbitals and 1 2p orbitals since the hybridization is sp. This is a new set of equivalent sp hybrid orbitals. This another 2 single electrons will be used in making of 2 pi bonds. So, we will label it as unhybridized 2p orbital. Next, we will look at nitrogen atom. Even though nitrogen is our terminal atom, it has multiple bonds. So, we need to show the hybridization of it. From the Lewis structure, we can see there are 1 sigma bond and 1 lone pair, indicates that it has 2 electron groups. The electron group arrangement and its molecular shape is linear. 2 electron group also indicates that it has sp hybridization. Okay, let's go to the first step. Valence electron configuration of nitrogen is 2s2, 2p3. So, the orbital diagram is represented like this. For the promotion of electron, have a look at the nitrogen atom. It has 1 sigma bonds and 2 pi bonds, so we need 3 single electrons in the orbital. Since there is only 3 single electrons, there is no need to promote any electron. Next, we need to mix 2s orbital and 1 2p orbitals since the hybridization is sp. This is a new set of equivalent sp hybrid orbitals. This another 2 single electrons will be used in making of 2 pi bonds. So, we will label it as unhybridized 2p orbital. Now, let's draw the orbital overlapping diagram. The sp hybridization has linear arrangement. First, draw hybrid orbital of sp and label each of it. The CH sigma bond is formed when sp hybrid orbital of carbon is overlapping with 1s orbital of hydrogen and 2n. The Cn sigma bond is formed when another sp hybrid orbital of carbon is overlapping with sp hybrid orbital of nitrogen. The first Cn pi bond is formed when 2px orbital of carbon overlap with 2px unhybrid orbital of nitrogen side to side. The second Cn pi bond is formed when 2py unhybrid orbital of carbon overlap with 2py unhybrid orbital of nitrogen side to side. Don't forget to label the atoms, orbital, and the sigma bonds.